Every discovery's got a story. What you're about to watch is the discovery and the history of Messier number 1, what we would call the Crab Nebula. It's an iconic deep space object whose story goes back about 1,000 years to ancient China and then goes on to span across several continents and nations. The mystery of the celestial guest, as the Chinese called it, has led to major discoveries that have had profound implications for astrophysics to this day. Capturing many firsts in the record books, understanding the Crab Nebula is a must for anyone who's genuinely curious and interested about astronomy and astrophysics. So let's start the story of the Crab Nebula here. So it's early morning in 1054 AD in China, and we're in the ancient Chinese Song Dynasty capital of Kaifeng. And the director of the Imperial Astronomical Bureau is a man by the name of Yang Guide, and he's fervently writing a message to the newly anointed Emperor Renzong of the Jihei era. In it, Yang tells of an auspicious celestial guest. It's pale red in color, and it's suddenly appeared at dawnbreak in the skies to the south. He talks about how that in broad daylight it blazes as bright as Venus, and it's slowly rising higher and higher in the sky. Recently, it's begun to shimmer like a bold yellow, which is the same colors as the imperial colors. So it can only be like a divine sign that the enlightened and worthy one has finally ascended to the throne. Yang Guide remarks that the star Tianguan guards this visitor, who has taken up residence next to it. Tianguan lays kind of near the Chinese constellations of the 5 chariots, Auriga, as we would call it, and the 3 stars or Orion in our lexicon here. That's a clue that's going to become really critical and important about 1,000 years down the road. Here's a view of the nighttime sky as people would have seen it during that era in the Song Dynasty outside the capital of Kaifeng. You can kind of see where the guest star would be in that picture. Now, the new emperor is totally pleased. He's stoked when he hears this news, and he sends congratulatory messages to all the men involved, to his everyone at the astronomical and the historiographical bureaus. It's believed that in commemoration of this celestial event, this new object seen in the nighttime sky, that the new emperor in the following months changes the name of his era from Jihei, meaning attaining harmony, to Jiao, which means auspicious aid, because this thing is helping them out, this object in the sky. However, not all who look up and see this new guest in the sky sees a prosperous sign. One man, Zhao Bian, is the palace censor, and he sees this interloper as pretty baleful. He sees it as a bad sign. A little background on Zhao Bian. He is out to get the emperor. He thinks that him and his entire corrupt cabinet, so to speak, are completely corrupt. He sees this thing as a sign that the corruption and malfeasance by various palace members are attracting divine rancor, that the gods are not happy, and this is something that you should definitely be fearing, not celebrating. So Zhao Bian has been really busy assembling evidence of wrongdoing for the last year in a case against the Grand Chancellor's office. And so he informs in his own communications to the emperor that for a year now, this trespasser's brilliance has not faded. Like, it's just not going away. And then he goes on to propound that this event is kind of anomalous to when Halley's Comet was seen back in the former Han Dynasty, and it was an ominous warning for the Han of their impending fall. So he implies that the same fate is going to stricken the emperor's reign if the corruption is not rooted out and the emperor doesn't put a stop to it and kind of like clean up in his ways. So in making his case of warning to the emperor, Zhao Bian even quotes the respected former Han Dynasty official Gu Yong, who said that this was an omen of severe disorder in the palace, and that rebellion and disaster are going to follow really soon and spread just all over the kingdom. Now, at the same time, to the northeast, you've got the Chinese kingdom of Liao, the Liao dynasty, and they also share the sentiment that this new star is not a positive sign. Liu Yisu is the editor-director of the Liao Palace Library, had kind of like a similar job. And so he writes a memorandum in retrospect, almost 2 years after the arrival of this guest star that's now just, relentlessly hovering in the sky there. And he states that following a solar eclipse, a midday guest star had appeared, and that this was considered an astral omen that the beloved emperor, Xinzong, is going to die pretty soon. So after some time shining brightly, the guest star fades and disappears, departs forever. And true to prediction, the emperor did indeed die shortly thereafter. Yang Guide of the Song Kingdom also notes that the celestial guest's departure in a second memorandum to the imperial court, kind of finalizing this chapter in the palace records of this event. it kind of goes under the radar and unnoticed for another 1,000 years. So many other cultures around the world also kind of recorded this event. However, it eventually faded into the annals of obscure history for centuries as the time marched on. Life goes on. But by examining these records of the Song dynasties, Songheo and Lao dynasties, Qi Dan Gaozi, Western astronomers and historians were kind of able to pinpoint the exact date of this guest star's arrival when it showed up in the sky, and that date was July 4th, 1054 AD. Now, it's a date that will someday become really relevant in connection to unraveling a growing astrological mystery. Now, we're going to fast forward a lot here. We're going to 1758 Paris, France. And it's been a long evening, and Charles Messier, an accomplished astronomer in his day, pulls his eye away from his humble 4-inch telescope, and he's really frustrated. He's like, nah, it's not a comet, as he kind of growls to himself here. He's been spending the last several nights on the roof of the Hotel de Cluny in Paris, staring at like a soft, fuzzy blotch in the evening sky. And he's kind of ardently searching for comets, and he's becoming really annoyed that all this time he just wasted was a total letdown. So he whips out a journal and he decides to make a list of things he sees that he confirmed are definitely not comets, lest he wastes his time on the same objects over and over again through his telescope. So he puts this faint splotch down as the first thing on his list of things to dismiss, and he dubs it M1. Now, his list of not comets, so don't waste your time, kind of eventually grew into be about 110 items long. But little did he know, like in another 163 years, his first entry, M1, would become a lot more interesting to astronomers than just some lousy not a comet. He probably should have given it a little more study and attention, as you'll learn why as this story continues. So keep listening. Now here's a fun one. We're in 1844, Birr, Ireland, and you got William Parsons, and he's like the third Earl of Ross, I believe, and he's in his castle, and he's like squinting at a sketch he just made after staring all night through his 36-inch telescope at what was called the Messier 1. It was a nebula. And he's thinking to himself, it kind of looks sort of like a crab, I guess. And he kind of goes and retires for the night. Now, here's a photo of Parsons' sketch of the Crab Nebula. Personally, I don't think it looks like a crab. I think it looks like a pineapple. If you see a crab, let me know. I don't know what Parsons was thinking. But a few years later, in 1848, Parsons upgrades to a bigger and better 72-inch telescope, and he decides to kind of give this viewing of the crab thing another go. He returns to it. And after studying the object, he concludes that, like, whatever it is, it sure as hell doesn't look like no damn crab. But by then, the name had stuck in the community, and so henceforth, the nebula M1 was called the Crab Nebula, even though it didn't look anything like a crab. So if you're looking at it and you're wondering how it got that name, that's how. Now, at the time, people were regularly observing nebulas, but they were really still a mysterious kind of thing. In astronomy, scientists really had no idea what they were. 70 years earlier from that time, William Herschel was one of the leading astronomers studying nebulas in his day, believed that the nebulas he was seeing were nothing really more than just faint star clusters. They're too far away to be seen clearly, so they just look fuzzy. But it wasn't really until he noticed one day that there was a star inside one of these fuzzy objects. So it couldn't have been a cluster of stars. So he decided it was more like maybe a cloud that surrounded a star. But it would still be a long time before scientists got really good traction into figuring out what the identities and origins were of nebulas. The first real clue that they got didn't come until like 1864. You had a guy named William Huggins, and he discovered that like a lot of nebula's light spectrums match that of excited gas. Therefore, the types of nebulas must really be clouds of gases that have been excited by the stars near them. So these nebulas were referred to as emission nebulas. So if you're ever wondering all the different types of nebulas, here's a basic breakdown. You got emission nebulas, which give off or excited gases from the star's output. Later, you got a guy named Visto Slipher, which is kind of a pretty cool name in my opinion. He noticed that a lot of nebulas, their light spectrums match that of the stars next to them. Therefore, they must be kind of like reflections of starlight on some of the particles that compose the nebulas. And he dubbed those reflection nebulas. So emission nebulas, excited gas. Reflection nebulas, dust reflecting the light from the stars next to them. But even with these important revelations about the nature of nebulas, nobody's really sure what caused things like the Crab Nebula to even exist. How did they get there in the first place? The mystery kind of went on. What created the Crab Nebula? So it's 1921. We're in Flagstaff, Arizona. If you've never been to Flagstaff before, it's in the United States. It's a really kind of pretty place. I like going there a lot. Carl Otto Lamplin is at the Lowell Observatory, and he's kind of viewing the Crab Nebula. And he's got like this nagging thought that's ruminating in his head. Something just doesn't look right. Whenever he looks at the Crab Nebula, it looks different somehow than how he remembered it like the last time he looked at it. Each time it seems just bigger somehow. So he looks at the nebula again and again, and he's like now adamant, like, dude, whatever's happened, the Crab Nebula, it's changed. So he kind of reaches out to the community, makes a public announcement of his observations, and he's seeking confirmation. So he's asking a lot of other scientists and astronomers and around the world, hey, can you take a look at the Crab Nebula? Tell me I'm not seeing things here. It's changing, right? So a few weeks later, you got John Charles Duncan, and he works over at the Mount Wilson Observatory. And he decides to look into the matter. He's like, yeah, sure, I'll take up the challenge. I'll take a look at the Crab Nebula. For a little bit of background, the Mount Wilson Observatory was a big deal in that time. It was taking up a lot of the work and making a lot of discoveries in astronomy. The observatory itself kind of lies nestled like high in the mountains that kind of serve as a backdrop to the city of Los Angeles. It's a pretty sprawling complex of telescopes that are kind of spread amongst like a whole cedar tree forest. It's really a fun place to kind of walk around. It's kind of enchanting. It sits over a mile up on top of the peak. And that observatory had been taking pictures on a regular basis of the Crab Nebula going all the way back to 1909. So they've got like a lot of like pictures to compare and contrast through time, the Crab Nebula. And so he's just the guy for the job. So he looks into it and he's switching back and forth between older and newer pictures of the nebula, and he does indeed see changes. It's growing in size. Not only is it growing in size, it's actually growing faster and faster with each year. Each time they take the photo, it's speeding up how quickly it's growing. As a happy coincidence, during this same time of year, you got a guy named Newt Lundmark, and he's collecting records of Chinese guest stars. It all circles back, right? And he's in a search for evidence of suspected novae. Novae was a term inspired by the 6th century works of Tycho Brahe, who was looking for new stars and what he would call de nova stella. And so Lundmark was one of the pioneers looking into this and trying to chart all these guest stars in the history books and old records. So anyways, he's looking for some new source material, and he stumbles across details of the events in China that were figured to take place in the year 1054, our favorite celestial guest year. And he knew that this guest star was located again near that star Tiangong, and he knew that Tiangong was known to us in the West as Zeddai Tauri. It's in the Taurus constellation. And so it dawned on him, hey, all this hubbub about the Crab Nebula making its rounds, everyone's talking about it, it's located exactly where this guest star in 1054 was observed to be located that had mysteriously disappeared. Now, in 1928, you got the legendary Edwin Hubble, and he decides he's going to look into this Crab Nebula thing too, and he realizes it's just not in the same vicinity, it is that guest star. The Crab Nebula is whatever became of this celestial guest that the Song Dynasty had seen 1,000 years earlier. But it took a guy named Nicholas Mayall measuring the velocities of the gases radiating out of the center of this nebula before the scientific community kind of accepted what the Crab Nebula truly was and what they were really looking at. He was like basically saying like, dude, look at how fast this gas is expanding. It's got to be from like the star exploding or something. So he proclaimed that the guest star of 1054 was actually a supernova, which was a totally new term back in the days. It was a newly coined term back in the early 1930s, and that this Crab Nebula was the still expanding remnants of it. So this is one of the firsts for the Crab Nebula in the history books. It gets to claim that prize. The Crab Nebula became the first recognized object associated with the supernova by science. Basically, the first confirmed observation of a supernova remnant, confirming that stars do explode. So soon thereafter, a lot of other nebulas that were connected to like ancient records of guest stars and celestial guests and novae that were observed in the past were discovered to actually be the remains of supernovas. But it was this whole realization with the Crab Nebula and unraveling that mystery that led to this chain of discoveries going, hey, those are supernovas. There's one, there's one, there's one. What did you know? Here's another one. So thank you, Crab Nebula, for setting that in motion. I'm going to fast forward to 1967. You're at Cambridge University in England. And so for like 3 months now, you got a woman named Jocelyn Bell, who later went on to have a spectacular career in astrophysics. She was a big name. But at the time, she's a PhD student, and she's meticulously inspecting seemingly unending reams of data, these charts that are just being produced by a 4-acre wide radio telescope that's a little ways down the road called the Interplanetary Scintillation Array. The telescope is scanning stars in the sky and is charting their radio emissions. So it's a radio telescope. And she keeps seeing what she calls a bit of scruff that keeps blemishing the charts on a particular location in the sky on these charts that are being printed out. And to make things even kind of more curious is that this radio pulse or this bit of scruff is repeating exactly every 1.33 seconds. So she hurries off, she runs down the hallway, she's excited, and she goes and tells her professor, Anthony Hewitt, of her unexpected findings. Now, together they kind of team up, they study their readings, they realize that whatever's making these signals, they know it's not from human interference, it's not a glitch in the machines or the equipment, and they don't believe it's from stars either. So they dub this anomalous signal LGM1, LGM standing for Little Green Men, kind of as a joke to the unnatural appearance of the signal. The then thought was being, if it's not us and it's not stars and it's not our equipment, who is it then? So maybe extraterrestrial civilizations are trying to communicate by sending these pulses into the great expanses of space. So they're on the lookout for these kind of things now. And so soon after, another repeating signal was discovered somewhere in deep space, and they figured whatever this is, it's totally natural, but it's a not understood phenomena, and we definitely don't think it's aliens reaching out to us after all. So they came up with a name for it, and they christened this phenomena pulsars. First time this word is used, this term. Now, Professor Hewitt, he went on to receive the Nobel Prize for discovering pulsars, even though everyone in the industry knew it was really his student, Jocelyn Bell, who had made the discovery. So even though Bell's contributions and deserving of recognition and prize, part of the prize was overlooked because she was just merely a student, in interviews later on, she says she didn't really feel slighted about the fact that she was overlooked in all this. Personally, I'd be pretty pissed off if I was her. She was the one who discovered it, but her career did skyrocket shortly afterwards. Everyone knew who was the brains behind this discovery, and it was her. So I guess it's all good. She went on to have a phenomenal career. However, just because they got a name for these pulsars doesn't mean anybody really knows what these pulsars really are. But one guy had a really great theory that these pulsars were an unusual type of star, somewhere between a white dwarf and a regular neutron star in size. So this astrophysicist went by the name Thomas Gold. It's his theory, and he stated this is a new novel breed of neutron star that would rapidly spin and create intense magnetic fields that would then produce these repeating radio signals that we were observing in these pulsars. But the scientific community is often very fickle, and they thought his theory was stupid. Frankly, they thought he was a quack. And so they literally refused him from presenting his theory when he asked at the first international conference on pulsars. Even though nobody else attending had any good ideas either, and all their theories were stupid too, they barred Tommy here from going to the conference and giving a presentation on what he thought these things were. But Tommy stuck to his guns, good for him, and a year later he was vindicated. The Arecibo Radio Observatory in Puerto Rico, that big dish that's sitting in the jungles of Puerto Rico in the mountains there, and you've seen it in things like the X-Files. It's now kind of defunct and fallen apart. But it discovered at the heart of the Crab Nebula another pulsar. And at that point, the community was basically forced to accept Thomas Gold's theory. Not a quack after all, he was right this whole time. So accepting Gold's neutron star pulsar theory kind of created a revolution in astrophysics and astronomy, particularly in the realm of solid-state condensed matter physics. Without this breakthrough, who knows where people like Stephen Hawking or Kip Thorne or any of those physicists that kind of focused their work on the theories of wormholes and black holes would be. And again, this Crab Nebula was the critical element in setting off the chain of phenomenal scientific discovery, particularly in solid-state condensed matter physics. No Stephen Hawking, no Kip Thorne without the Crab Nebula here. So, Crab Nebula, as you're seeing, is kind of a big deal. Charles Messier probably should have studied it a little bit more instead of getting mad it wasn't a comet that he couldn't get paid on. But let's talk about the Crab Nebula. Now we've kind of got some history, and we'll return to some more history in a minute. But it's located about 6,500 light years away. It's about 11 light years across, and it's still growing, as we know. It's in the constellation of Taurus, or just outside of it. It's expanding at a rate of about 930 miles a second. Now, the Crab Nebula is a very unusual nebula in the sense that it's not really some simple emission or reflection nebula, nor is it like a typical supernova remnant. It's more like a separate nebula inside of a supernova remnant. The closest analogy or a sister nebula to it would be something like Eta Carinae, seen in the southern hemisphere, which is a supernova remnant. But at the heart of it, you've got the star Eta Carinae, which is another nebula called the Homunculus Nebula, which is a pretty cool one. It kind of looks like the Death Star exploding, in my opinion. But similar kind of thing. So a very unusual kind of nebula, the Crab Nebula here. When you look at photos of the Crab Nebula, you'll see like intensely whitish yellow colored tendrils. Those are knots of helium and hydrogen that are expanding outwardly into space. Near the fringes, they kind of turn into a deep reddish, orange, delicate, kind of lacy kind of thing. But at the heart of the nebula, in total juxtaposition, is a bright blue glow from electrons that are traveling just below the speed of light. And that kind of bathes its interior with this like bright whitish blue glow. Here's a close-up of the nebula's helium and hydrogen filaments, mostly created from the atmosphere of the star that went supernova before, leaving that collapsed neutron star in the center in its place. Now, at the core of this pulse, surrounding this pulsar, is what's known as a pulsar wind nebula. That's the nebula inside a nebula, so to speak, that I was referring to a minute ago. It's a she-shell-shaped nebula, and it creates like distinct sharp boundaries where the shock waves of the pulsar's like shockingly powerful solar wind impacts and batters the debris of the supernova remnant. These shock fronts are very dynamic. They can be seen changing every week on a weekly basis. So every time you're to look at this nebula inside of the Crab Nebula, it'll look a little bit different. In fact, the whole center of the nebula, again, thanks to this pulsar, functions sort of like a giant synchrotron. It accelerates electrons near the speed of light, and it's emitting like huge, abundant amounts of like X-rays. It's a massive source of X-rays. Let's do a little bit of a close-up on this pulsar itself. It's called Pulsar PSR B0531 plus 21 at the center of the Crab Nebula. Now, this image here is a composite of both the visual light, which is in red, and the X-rays, which is in blue, that are emanating from the pulsar. Note the bright white shock fronts that give it that seashell sort of shape. That's from the pulsar winds, hence why it's called a pulsar wind nebula. Now, recently, a mystery has kind of stunned astrophysics communities around the world. It's been observed, particularly by the Veritas Array in Arizona, that this nebula's got gamma ray radiation at energy levels like around like 400 giga electron volts. That sort of periodically erupt out of this pulsar nebula inside the Crab Nebula. Years earlier, the Fermi telescope was spotting these eruptions too of gamma rays at like 100 giga electron volts, and they sometimes last like 6 days in length, which is pretty long. And the problem is that pulsars aren't supposed to be able to generate photons on this energy level. It's off the charts here. So to put things in perspective, 100 giga electron volts to 400 giga electron volts, and just how really powerful that is. Think of antimatter. Matter-antimatter annihilations only produce gamma rays at 500 kilo electron volts. And this is at up to 400 giga electron volts. So the physics being used to explain how this can be possible is kind of staggering in its implications. The physics of pulsars are pretty complex, and they're way more complex than we imagined, and they're pretty strange. Like, for instance, the Crab Nebula pumps out optical light at wavelengths that we can kind of see at a steady, unwavering rate. And the same generally would go for its inner nebula pumping out those X-rays, or so they thought. But these eruptions or flare-ups kind of come as a complete surprise, and they're like 30 times stronger than what's average for the nebula. And they don't really kind of have a good grasp of why they're happening or how they get that strong. But studies have shown that although the neutron star forming the pulsar in the Crab Nebula is only 12 miles in diameter, because it spins so fast at 33 times a second, its magnetosphere creates like a superconducting column of plasma about 620 miles in diameter, which is where these electrons are kind of being shot up to these hard-to-fathom power levels, basically when they jump between gaps in the magnetic field lines and flux lines. So this is the source of the regular output, but they're kind of a bit puzzled by the exact mechanism of how these huge flares and eruptions occur that just go off the charts that I've been talking about. They know what happens in the superconducting column, and so the leading theory is kind of like the outer magnetic field lines sometimes meet head-on while traveling in opposite directions, and they kind of reorganize when they slam into each other, and this is what sets off these unprecedented gamma flares. It's a subject of study that's going to be going on for a long time with physicists if they can kind of come up with a concrete theory and work it all out. But regardless of the physics needed to produce such a phenomena, the Crab Nebula is again another record setter. We're just on a roll with the setting records here. It's the first discovery of ultra-high energy cosmic rays. The Crab Nebula also sets the record for the most powerful photons and cosmic rays ever observed by humans anywhere. Nothing even in labs can kind of reach the magnitudes of the energy output by these photons that the Crab Nebula creates. So in the meantime, the pulsar inside the Crab Nebula is used by astronomers to calibrate their X-ray telescopes. It's a handy tool right there in the nighttime sky. It's even got a unit of measurement named after it called the millicrab. But true to the form, the Crab Nebula kind of keeps surprising astrophysicists with the unexpected. Lately, they've noticed that these wavelengths of X-rays that are normally like steady, not these flares, but just the regular background X-rays that it's creating, they're fluctuating now at 3%, something they've never really seen it do before. So for most calibration of instruments using the Crab Nebula, that barely throws anything off. It's pretty imperceptible. But if you're really looking to get like really sensitive experiments going, it totally throws out like whatever results are to be completely unusable. So it's kind of throwing a monkey wrench into people using the Crab Nebula here as a unit of measurement. But and they believe that whatever's going on is these pulsar winds that are the source of these funky fluctuations. Now the Crab Nebula's still got one more mystery. There's more. The weight of the nebula kind of falls really far short of the mass of the star that created it and went supernova. Nobody's really sure where the bulk of this missing matter disappeared to, or how. Where is it? We don't know.
So next time you're looking at the nighttime sky, find the constellation Orion. There at Orion's head, go a little bit north of a wee ways, and between Orion and a little bit north of Taurus is where you will find the Crab Nebula. You may not be able to see it with your naked eye, but just know that you're looking at one of the most valuable pieces of real estate in the nighttime sky for astrophysicists and astronomers alike. Thank you.